Hey everyone, it's Miss Bell here from the Science Lab, and today I'm going to be talking to you guys about something really cool as far as weather goes. These two examples are examples of severe weather. That means that they are extremely powerful and extremely dangerous if they build up enough energy as they grow in size and in power. So the two types of severe weather conditions that I'm going to be talking about are tornadoes and hurricanes. Ah! Hope you guys are ready. Let's get to it. So when you're talking about tornadoes, that is just a big funnel cloud of air that is rotating around and around and around. And this air, powerful and strong, is only really considered a tornado when it hits the ground. It goes through different stages, from when it's developing high in the sky to when it starts to get lower and lower and starts to become more mature. And when it finally touches the ground, that's when we consider it a tornado. But tornadoes start from supercells, which are really big thunderstorm clouds up in the sky. And tornadoes are super destructive depending on their speeds, how fast the wind is going. Tornadoes are known to uproot trees and destroy buildings. They can move cars through the air or just down the street by these huge, powerful gusts of wind. And did you know that there can even be more than one tornado at a time? That's really scary if you're in that same location of where a tornado is forming. And in an entire year, there can be up to 1,200 tornadoes. That's 1,200 tornadoes in a year. And there are different characteristics of a tornado. One can be the shape. What does that shape look like of this particular tornado? How about the size? Is it as small as 2 feet wide or 2 miles wide? Even the speeds can be different from tornado to tornado, as low as 65 miles an hour all the way up to maybe even 300 miles an hour. And tornadoes even come in different colors when we see them happening during the day or the evening. They could be kind of invisible, they could be white or gray, they could have a greenish color, black or red. It just depends on the location and all that different colored debris that it's picking up from the ground and moving in that gust of air. Even the rotation of a tornado is different from the hemisphere that it's happening in. In the northern hemisphere, like where we live in the United States, tornadoes spin counterclockwise. And in the southern hemispheres, they spin clockwise. So many different things to think of when it comes to tornadoes, but they can be super dangerous as that energy builds up and as those winds get stronger and stronger and faster. So tornadoes begin in this big cloud up in the sky, this big storm cloud. We call this a cumulonimbus cloud, and it's made up of warm, moist air. And these clouds can get really big, really wide, and sometimes even really dark because it's a big thunderstorm. They can also grow really tall, and there's lots of lightning and rain coming down from these clouds. You might also get hail, which is frozen rain, almost like a sphere or ball shaped, and strong winds. Now, when there is air near or above the ground and it's warm and humid, that air will begin to rise from the ground and go toward this cumulonimbus cloud. And as that air starts to lift up and come into the cloud, it kind of creates what we call an updraft. It's going up, 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 and pulling that warm, humid air up into the cloud. As that warm air rises and gets higher and higher and higher into the sky, it's not going to stay as warm as it once was. It's going to start cooling off. And when this air starts cooling off, condensation is going to start occurring, and that's where we get the rain or even the hail. And as that air kind of cools off, it's going to fall back down to earth. This circular motion of warm air rising, getting cooled off, and then cool air sinking, we call that convection. Kind of makes this like circular motion, just depending on the temperature. Warm air rises, cool air then begins to sink, and as it begins to come back down to earth, it then creates what we call a downdraft. So an updraft, it's going up, and a downdraft is going down. Now, if this updraft and this downdraft kind of come together, then it might cause all of that craziness air in the sky to create almost like a funnel-shaped cloud, and it might form like a funnel of that strong circular air, which is kind of the beginning of a tornado. And if it comes down, down, down to the ground, well, we know once it touches the ground, then it's considered a tornado. Tornadoes can happen at any time during the year, but in our country, in the United States, we get most of our tornadoes in the late part of spring and the beginning part of summer. So that would be April, May, June, maybe even July, and we are right about there. And when you're talking about tornadoes, the funnel cloud is going to start spinning faster and faster, faster. It's going to suck up a lot of things and debris and objects that are on the ground. And as more and more of that warm air starts being brought up into the sky and the cool air down, it just gets faster and faster and bigger and louder and more powerful. And that's the extraordinary factor of tornadoes. They are fascinating but scary at the same time. So I want to show you a simple experiment that you can do in regards to convection. And when I talked about it earlier, it's the movement of warm and cold. In this instance, we're going to be looking at it through water, but when you're talking about tornadoes, it's the warm air and the cold air and the circular movement of those two different temperatures. So for this experiment, I took a clear jar and filled it with really, really cold water. Then I took a small clear cup, and which is actually a beaker, and I filled it with hot water. Now I wanted to see the difference between the hot water and the cold water, so I added food coloring to my hot water that was inside my beaker. Then I put a covering on top of my red hot water with a piece of saran wrap, like clear plastic wrap. And then I tied it off with a rubber band just to make sure that it is secure and stayed in place. I then put my hot water container inside my jar of cold water, but I made sure I used a pair of tongs so that I didn't really burn myself, and that I could place it carefully in my container of cold water. And last but not least, I carefully used a sharp knife to dip into my cold water, go all the way down to where my hot water is at, and I poked a hole in that plastic wrap. And as that hole opened up, we were then able to start to see the movement of what's happening between the cold water and the hot water as it's starting to escape from my hot water container. We can see that red warm water starting to rise up into the colder water. It's getting higher and higher and higher. We can see the red at the very, very top of our cold water container. And as we continue observing what's happening before us, we would then be able to see that as the cool water and the warm water start to kind of mix together and the temperatures start to kind of settle and get closer and closer to the same type of temperature, it's going to make like a circular motion. We're going to see that red colored water sink lower and lower and lower into our larger jar. And this is what we would call the convection cycle. I know it's a big, big word for second grade, but it's just the rising and the falling of warm air and cold air. So about 50 years ago, a man named Mr. Fujita came up with a scale on how to classify tornadoes. And he kind of based it off of the wind speed of the tornadoes, you know, how slow or how fast and extreme those winds are blowing, and what kind of damage is happening to that local area that's being affected by the tornado. And about 50 years ago, he came up with this scale, kind of numbering the tornadoes from, you know, it's a tornado, but it's not too dangerous, to, oh my goodness, this is extreme, this is powerful and massive. So they used to be labeled or categorized as F0 to not that extreme, all the way to F5. Now, about like 15 or so years ago, that scale has been enhanced with new information and new kind of ways to rate the different categories of tornadoes. So instead of saying kind of like a F1, F2, F3, we now say an FE0. So it's enhanced, Fujita enhanced, and then you say the number FE0, FE1, FE2, all the way to 5. And again, it just depends on how severe that damage is during the tornado and the after effects of the tornado, and then kind of those average speeds of the wind. So with a tornado that's classified as a 0, this is going to have wind at speeds anywhere from 65 to 85 miles per hour. During a tornado like this, we can see broken tree limbs, maybe some damage to chimneys on houses, and a little bit of roof damage. So not too bad, even though it's still considered dangerous. Now, if you jump to a tornado categorized as a 1, that's where the winds get a little bit stronger. So anywhere from 86 miles per hour to 110 miles an hour. Here you're going to start seeing maybe some of those roofs being peeled off of barns, or maybe cars are being pushed and moved on the roads, or even overturned cars. Now with a Category 2 tornado, this wind is getting even more intense. So anywhere from 111 miles per hour to all the way to about 136 miles per hour. Here you're going to see rooftops that are being torn off. Large trees are going to be pushed down, and even those roots are going to be uprooted from the ground. And Homes that aren't very strong, maybe like a mobile home, they are going to be destroyed or even demolished. Now, a Category 3 tornado, this is meaning business. Those winds are getting all the way up to 137 miles per hour to maybe even 165 miles per hour. This is where you're going to see those stronger homes. Well, the roofs and the walls of those stronger homes, they're going to be destroyed or torn off and blown all to bits and pieces. Even heavy cars are going to be lifted up off the ground, not just the kind of lightweight cars. And certain Category 3 tornadoes have had forests being uprooted, all those trees being taken from the ground, lifted and thrown through the air. Now, a Category 4 tornado, again, these winds are getting stronger and stronger, so it might be anywhere from 166 miles per hour to about 200 miles per hour. The homes, the foundation underneath the homes, well, those houses, these strongly built houses, can be blown off of those cemented foundations. The roofs can be pretty much just almost like decapitated, can be completely destroyed. These cars are thrown all throughout the air. Trees are going everywhere. And the most severe type of tornado on that scale is a Category 5. This is extremely powerful. Those winds are going over 200 miles per hour, and with this type of tornado, you're going to see even heavy-duty things being lifted into the air, carried around, and dropped miles away from where they were originally found. This might be heavy trains, heavy buildings, big machinery. Even these homes can be lifted up, carried, and then dropped on the ground and destroyed. Now, most of the tornadoes that happen in our country, in the United States, happen usually in a specific area. Take a look at my book right here, especially my map. In the middle of all kind of our 50 states, there is a section, and we would call this section or this area right here Tornado Valley. So once the months of April, May, June, maybe even July start happening, there are a lot of tornadoes that happen in this area, Texas being a part of it. And about 20 years ago, in that Tornado Valley, there was a specific date, one day, May 3rd, 1999 to be exact, where there were 96 tornadoes. 96 tornadoes that happened on that one day in the Tornado Valley. And that is extreme, severe weather. That's not normally what happens. Usually there might be one tornado that happens. You might see more than one, maybe 2 or 3 happening at the same time. But to see so many tornadoes happening and coming from the sky and hitting the ground all in the span of one day, that is just extreme. And Oklahoma, the state of Oklahoma, right north of Texas, that might have been the state that got hit the hardest. All the damages that happened in Oklahoma reached a cost of about $1 billion. $1 billion. Think of how much damage would have to be done to an area to cost that much money. So tornadoes are not something to be taken lightly, and can grow and become extremely dangerous in the matter of maybe seconds or minutes, depending on how fast those speeds start to build up. So here I am with my daughter Rain. Hi. And we're going to make a tornado in a bottle. Here we go. So Rain has some water. She's going to drip some food coloring.
How many?
Maybe 3. About 3 drops. And it all depends on how dark you want your color, but we're going to go for a nice green. She's going to take that plastic spoon and stir the food coloring around.
Gently.
Gently, yeah. We don't want a dirty science lab. And then she's going to take the cup right here with the handle, and she's going to pour it carefully into one of our 2-liter soda bottles. Remember, it doesn't matter what size bottle you use, just as long as you have 2 bottles and they are the same size. You'll also want to peel off the labels on your bottles so that you can see the effect of the tornado happening in the bottle.
Which is hard.
Yeah. And you want to make sure that you rinse out your soda bottle before you get started on filling it, because you don't want the soda mixing with the water. It's going to make a kind of a gross color and it might not last as long. So we're going to put this aside. Yep.
Yeah.
And then Rain's going to add some cool glitter inside the top of the bottle. Here we go. Carefully, carefully, carefully. And again, this is all depending on how much glitter you want in your bottle. A little bit, an average amount, or a lot. And then we are going to attach our 2 bottles with one of our little connector. And one bottle goes on top, one bottle goes on bottom, and you just kind of screw them right next to each other so that your little tornado in a tube, here you go, babe.
It's tight.
Yep. Is really, really tall. There you go. Okay. So let's scoot this cart out of the way, and Rain is going to show you what it looks like with the 2 bottles. There we go. Yep. Oh, and lo and behold, look, Miss Belle is already prepared. So she has the bottle we just made. I have 2 bottles that I've already made, and we're going to show you some cool tornadoes here in the science lab.
This has less water.
It's okay. Are you ready?
Wait, I'm going to mix the glitter up.
Yeah. If your bottles have been sitting for a while, you might need to mix them up a little bit to get that glitter going. And then all you do is turn your bottle upside down. Ready and go. And you give it a good circular shake. Circular shake. Circular shake.
Mine is not going.
Turn it down so that they can see the tornado. There you go.
Mine is over here.
It's okay.
Let me do the
You try this one.
I'm better at this one.
Ready? I'm going to go again. Rain's about to do a new bottle. Ready? And circular, circular, circular motion. Put it down so that they can see. Oh, yours is like really, really thin tornado. Mine's really fat. Okay, I want to do it one more time.
Okay.
You want to do it one more time?
Yeah.
Okay, ready?
Wait, should I try both?
How about I try both?
Oh,
okay.
okay.
Ready? Here we go. And go.
Oh, mine's thin again.
Ooh.
Like the top. No, now it's getting fatter.
Oh, how cool. Yay. So the second type of severe weather I want to talk about is hurricanes. And in a way, tornadoes and hurricanes have some similarities, but they also have some differences. I want you to take your finger and I want you to make kind of like a small little circular twirl. Yeah? Let's consider this a tornado. Now take both of your arms and make like a big circular motion with your arms. Well, if you were to compare those 2 sizes, this is a hurricane and this is a tornado. So size is a big factor when you are comparing tornadoes and hurricanes. Also, kind of where they form. For the most part, tornadoes are on land, even though there are some that do start on waters, like lakes or maybe even an ocean. But hurricanes have to start over water. And particularly, they start in warm water, and we're going to find warm water near our equator. So kind of like tornadoes, it's a convection movement of warm and cold, moving and connecting with each other. And with a hurricane, this is a tropical storm. You're going to get heavy rainfall and super strong winds, but not as strong as a tornado's winds. As the water above the ocean rises, that warm air rises, it's going to cause that surrounding air to be kind of sucked in. And as these clouds are forming on top of all of this air, of the warm and cold air kind of moving up and down and rising and lowering, these clouds are forming. Those clouds are going to start rotating, and then this is where we get a hurricane. Now, a hurricane can move over the oceans and just stay on the oceans, but they can also move over land, and that's where it gets serious for us humans and our belongings, our cars, our homes, our landscapes. So sometimes a hurricane can go by different names, such as a typhoon or a cyclone. And really, these three types of tropical storms are the exact same thing. The only difference is the location of where they happen on our planet. And you have to take into consideration where they are located and in which parts of which oceans. Take, for instance, cyclones. You are going to find this type of tropical storm in the Indian Ocean next to Africa and India and Australia, and also surrounding Australia, kind of on its eastern border, you're going to find cyclones there. But typhoons, like my yellow tropical storm up here, that's going to be on the eastern part of Asia, so kind of in the Pacific Ocean over here, kind of in that northwest Pacific Ocean. But hurricanes surround our continent and our country. Hurricanes can be found in the Atlantic Ocean and on the western part of North America. And the way that these tropical storms rotate, either counterclockwise, so the opposite way of a clock, or clockwise, the way that we see clocks going, depends on whether they sit north of the equator or south of the equator. For the northern hemisphere tropical storms, those are going to rotate counterclockwise. And the tropical storms that happen on the southern hemisphere of our planet, those are going to rotate in the opposite direction, or we would call this clockwise. So I'm going to show you what a hurricane looks like if we're looking at it from above. So what I have here is a metal pie pan. I have some water off to the side. I have red food coloring, and I have a couple pieces of wood. And this is important to use wood because wood is less dense than water, and it will float when you put it in water. So the first thing I'm going to do is fill my pie pan with water. I want a good amount of water in there. I want a good depth, because this is important when we start to see that circular motion from our tropical storm. So the next thing I'm going to do is I'm going to take something to stir with, and I'm going to stir in whatever direction my tropical storm is going. Right now I'm going clockwise, and that means we are looking at a tropical storm in the southern hemisphere. So stir, 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 make sure it's going pretty fast, and at the same time I'm going to drop some food coloring in my tropical storm, and then I'm going to stop stirring. Here we go.
Yep.
And slow enough, we are going to be able to see what it looks like in our tropical storm. Now, I put my 2 wooden pieces so that you can have a visual of how fast the inner part of our hurricane looks, the eye of the storm, and how slowly the outer parts of our hurricane spins. But this is that circular motion that we are going to see from our hurricane. I'm going to do it one more time. Here we go. Stir, stir, stir. Fast, fast, fast. Clockwise. Then I'm going to drip my food coloring. And then I'm going to drop my wooden pieces so that you can see how fast it goes in the middle and how slower it spins on the outer parts. The last thing I want to show you is kind of some different wind speeds. And we talked about those fast winds in tornadoes, and hurricanes also have fast winds. So I'm going to try different ways that I can create wind to see what a house might look like when it's being affected by strong winds. First, I'm going to try just creating wind with my mouth by blowing air out of my mouth. You can see the tree leaves are kind of blowing, but not much else is happening. After that, I'm going to pick up a stack of plates and I'm just going to fan them over and over and over to get a little bit stronger wind. We can see more movement in our tree, and we can see a little bit of movement maybe in the car or the rock. Next up, I'm going to use a hair dryer, and this is using electricity, so it's going to produce a lot more wind than I'm able to get either out of my mouth or by using my hand movements. And we can see stronger winds from this blow dryer, blowing the tree even harder, moving those rocks and moving and pushing my cars. Next and finally, I'm going to use a big fan like what I used a while back when trying to show you guys what it looks like when birds hibernate. Now this fan is super strong, and you can see how my whole cardboard place with my house is moving. In fact, it flipped over. If I hadn't been holding it down, or it hadn't been held down by rocks, the whole thing would have been lifted up, thrown across the room, and then crashing down on the floor. So that's all I've got as far as tornadoes and hurricanes go. Just remember, tornadoes and hurricanes have very similar things about them, and they also have differences depending on their size. Hurricanes are huge. Tornadoes are kind of smaller in comparison to size, but tornadoes are faster, and hurricanes still have a good amount of speed, just not as severe as that tornado wind speed. Some can occur over lands, like tornadoes. Some occur over oceans, like hurricanes. They're kind of cool to learn about, but they can be very, very serious and dangerous. So, thanks for joining, guys. I'll see you later. Bye.